Hello ladies and gentlemen, let us meet in our 8th lecture in which we are going to look at the industrial electrolytic processes. This is when we have the application of the process of electrolysis in the manufacture of some different chemicals. So there are main industrial processes that make use of electrolytic cells. But we are going to look in the manufacture of chlorine, that is in lecture number 8, and in lecture number 9 we are going to look at the recovery of aluminium, both of which are being carried out in South Africa. So chlorine itself is being manufactured by one of two processes. We have the process which we call the Kastner-Kellner process. Maybe you want the spelling for Kastner, Kellner process. This one was named after the American Hamilton Kastner and the Austrian Karl Kellner in the 1890s. These are the one who actually designed the flowing mercury cathode. However, this particular chemical electrolytic process is no longer being in use. Why? Just because the mercury which is being used in this particular process is highly toxic, and mercury waste is extremely harmful to the environment. So this particular process is being phased out in preference for the membrane cell. However, we're having some advantages in using the flowing mercury cathode. Number one, we have the fact that sodium hydroxide obtained is highly pure. The process itself is very efficient, and the possible reaction between sodium hydroxide and chlorine is avoided as sodium hydroxide is obtained in a separate chamber, right? And the other disadvantage which we have is of high electricity consumption, apart from that one which we have said that mercury itself is highly toxic. So now that's why we see to it that we are not using the flowing mercury cathode because of its harmful effects to the environment. So we are using the membrane cell. This one is the membrane cell which is being used for the industrial preparation of chlorine, right? This type of cell electrolyzes dilute sodium hydroxide solution. This one is also called brine, and we see to it that the chloride ions move to the anode where chlorine gas is going to be produced. So as you can see, we have our chloride ions which are being obtained from the electrolysis of our sodium chloride. We're going to form some sodium ions and the chloride ions. So we see to it that our chloride ions are going to be attracted at our anode there, which we have the titanium anode. Remember, in electrolytic processes, we have said that our anode is positively charged and our cathode itself is negatively charged. So in this case, we're having the steel cathode. So our anode reaction, we see to it that our chloride ions themselves, they are being actually oxidized to chlorine gas by losing 2 electrons. So that is what we see from our chemical reaction. We see to it that chlorine gas itself is being produced. So if we are going to see from our diagram, we see to it that our chlorine gas is actually being produced. That's why we are saying here we're having chlorine out. So it happens at the anode. So this one itself is an oxidation reaction. right? And now we see to that at the cathode, right here at our cathode, which is negatively charged, we see to that we have our hydrogen there is being actually produced. So we have our hydrogen is being produced from our water. So we have our water, which is in liquid form, plus our 2 electrons, and then we're going to form hydrogen gas, plus the hydroxyl ions, right? As you can see from this particular reaction, we see to it that our water there, which we have, is actually going to be reduced to hydrogen gas and some hydroxyl ions, right? And now what we are going to see is that we are having our sodium ions, which we have actually electrolyzed on this side of the anode. We see to that we are forming sodium ions and the chloride ions. The chloride ions are the ones which are being attracted at the cathode, and they are going to actually oxidize to chlorine gas. But however, our sodium ions are positively charged. They can't be attracted at the anode. Therefore, they are actually going to move across our porous asbestos membrane, right? And as a result, we see to it that we are having these hydroxyl ions which are being produced here from our reduction reaction of our water. We see to that they are going to react with the sodium ions, and then they will form sodium hydroxide. So this one is the caustic soda, which we see, which is moving out there, right? So the purpose for our porous membrane is to prevent the solution from mixing, but it allows the ions to pass from one compartment to the other, so that the sodium hydroxide is removed from the cathode compartment. Remember, we have said our sodium ions are the ones which are moving across our porous membrane, and at the end of the day they will react with the hydroxyl ions, and we have the production of sodium hydroxide. So the asbestos from which the diaphragm is made is toxic, so alternatives are also being sought, right? So that is what we have as far as our industrial preparation of our chlorine is concerned. So what you are supposed to make sure is, in this compartment we are having the production of hydrogen gas. So you are supposed to know that we are having a reduction reaction in which our water is being converted to hydrogen gas and the hydroxyl ions. And these hydroxyl ions are going to react with the sodium ions which are moving through the porous membrane, and then we form caustic soda. So in this particular industrial preparation of chlorine, we have some advantages in the sense that we are having 2 other important products which we are actually going to get. We have hydrogen gas, and we are also having caustic soda on top of our chlorine which we are producing here. So this industrial preparation of chlorine itself is really an advantage in our everyday lives. Why? Because we are also producing 2 other useful products. So you are supposed to actually stay tuned for lecture number 9, where we are going to see the recovery of aluminium, how aluminium itself is also being produced, and this particular process is also being done here in South Africa. So stay tuned for lecture number 9, the industrial preparation of aluminium.